Hello, ladies and gentlemen. Let us begin lesson chapter 6.6. This is the last section in this chapter for advanced algebra. All right, so we're going to solve some radical equations. So you can see in number 1, we have x plus 5 in the square root minus 4 equals 6. Step 1. We want to get the radical by itself. Anything that is not inside the radical, get rid of. So in this case, that would be the minus 4. So we're going to have to add 4 to both sides. Okay, the radical is now all by itself. It is isolated. Now we're going to get rid of the radical. So to get rid of the square root, we are going to square both sides. Okay, always remember what you do to one side, you do to the other. When we square both sides, the square and the square root cancel each other out. So now x plus 5 equals 100. And then the last step, just like any equation, our goal is to get the variable by itself. We are going to subtract 5. So our answer to this problem is x equals 95. All right, let's go to the next one. So again, following the steps, we want to isolate the radical symbol. So we want to get rid of everything else around it. So we are going to first divide by 3. Again, to get rid of the square root, we are going to square both sides. And get x by itself, all we need to do now is add 2. And x equals 18. Next. All right, in this one I threw both things in there, so we're going to start by getting rid of the minus 5. Okay, now we have a fraction in front. Do not divide. Okay, we want to multiply by the reciprocal. And the reciprocal of 1 over 2 is just 2. So we're going to multiply both sides by 2. Okay, now it's just like the first two. We're going to square both sides to get rid of the square root. And subtract 1. All right. Let's go to the next one. Okay, this one has a cubic root. So to get rid of a cubic root, Okay, first of all, there's nothing around the cubic root on the outside to get rid of, so we don't need to worry about that. So we got to start by getting rid of the cubic root. Okay, and to undo a cubic root, we're going to cube both sides. And get rid of the 3. And voila, x is 61. Okay, this one, start by getting rid of the 2. Get rid of the cubic root. Now when you do these, you should, since that is a -5, get into the habit of putting parentheses around that, because that could affect the answer with some situations. It won't happen in this scenario, but it could. Okay. Okay, and get rid of the -1, and we've got our answer. All right, moving on. Okay, on this one, you notice we've got a 2 on the outside, so we're going to get rid of that by dividing. Cube both sides. Add 3. All right, let's do one more, and then we're going to move on to a word problem. All right, notice this one says the 4th root, so just like the others, if you've got a 4th root, to undo that, you're going to have to use the exponent of 4, so use to the 4th power. May the 4th be with you. Little Star Wars reference there, ladies and gentlemen. All right, 2 to the 4th power is 16. So we find out that x equals 15. All right. Next, we're going to do a little word problem here, and forgive my drawing. I'll do the best that I can with this so that we can visualize it as we solve this problem. So here we go. So if an 8-foot ladder is leaned against a wall, the height of the ladder along the wall is given by the function h of x equals the square root of 64 minus x squared, where x is the distance along the floor from the base of the ladder to the wall. Estimate the distance that the ladder should be placed from the wall in order for the ladder to reach 7 feet off the wall. All right, so here we go. So let's imagine we've got a building. Okay, here's a building. Put some windows in it. Okay, here's our wall. Okay, here's the ground. We're going to lean a ladder against it. Okay, that's the ladder. So let's see. X, well, it's an 8-foot ladder. Let's mark that. So 8 feet. So the ladder is 8 feet. The distance from the floor to the base of the ladder is X. So this is X. We want to know, well, nope, one more piece of information. It also says that, so we want to know how far away the ladder should be from the wall in order for it to reach 7 feet. So 7 feet up the wall. All right, so there is our little diagram. And our function h of x equals the square root of 64 minus x squared. Well, h of x is the height of the ladder from the wall. No, the height of the ladder up the wall. So the h of x is our 7 feet. So I'm going to rewrite that. 7 equals the square root of 64 minus x squared. Okay. Well, our goal is to solve for x. So we got to get rid of the square root. So I'm going to square both sides. So that would be 49 equals 64 minus x squared. Aha. All right. Now I'm going to subtract 64. So now I have, let's see, I have negative 15 equals negative x squared. Aha. Sorry about that. I jumped to the wrong screen. Okay, so I got to get rid of this negative x squared. So I'm going to divide everything by negative 1. So positive 15 equals x squared. Okay. So I'm going to rewrite that. X squared equals 15. All right, so I'm just going to rewrite it. Now, I want to get x by itself, so we square root. And we got to remember the plus minus. So x. Now, I am going to find the actual decimal of this one because it doesn't, you really don't know what the number is unless you have the decimal. So I'm going to do a little squiggly equal sign here because it's going to be approximately plus or minus, okay, the square root. Let me pull up the calculator. The square root of 15. So we're going to round it to 3.9. But you can't have a negative distance. So we'll use the positive. So the distance from the base of the ladder to the wall is 3.9 feet. Okay, the negative would not be used. All right. Now, we need to look at a couple of other types of equations, like this one. Okay, we kind of did some of this in our first lesson. Okay, except we didn't have rational exponents. So here we go. So first thing we're going to do is we're going to add 9. Okay, now to get rid of the 2/3, we're going to use the reciprocal. So the reciprocal would be 3 over 2. Remember, what you do to one side, you do to the other. Okay, on the left side, those cancel out. We're left with. Now, since the numerator is even, there will be 2 answers. So when I do to the 3/2 power, first let's do that on the calculator. So we're going to go 25 to the 3. Remember, those of you with the old calculators, you're going to have to use parentheses. 3/2 power. We're going to get 125. But when we write that, we need to put positive, negative 125. 2 answers. Now we're going to add 4. So one answer is going to be positive 125 plus 4, which is 129. The other answer is negative 125 plus 4, which is negative 121. So both of these are the answers. Now, if you go back and check them, plug it back into the problem, they would both work. Now, on a standardized test, I have seen this before. They would give you, like if this was a multiple choice test, they might have A, 129. Okay, so if you didn't realize there were 2 answers, you'd probably pick that one. They might also then have B. Okay, let me get my thing to write the B here. Come on. Okay, that one might say negative 121. Then they might have something like this. They might say both A and B, which obviously then you would have to pick that one. Okay, so be aware on standardized tests you might run into that scenario. All right, let's do another one. All right, so here you will notice that that is odd. The numerator is odd. That means there will be 1 answer. So we don't have to worry about a positive and a negative. All right, so we're going to get rid of the 5/2. We're going to do the reciprocal. And if you type that into the calculator, 2 to the 32 to the 2/5 power is 4. And so take away 3. Our answer is just plain old 1. All right, let's move on. We got one more thing to talk about. I'm going to skip this next problem. Okay, if you want to do this problem, the answer ends up, oh, I don't have the answer written down. So you figure that problem out, but we're going to skip it. Okay, we are going to run into some extraneous solutions. So, do you remember what extraneous solutions are? Okay, they are solutions that don't work. That means you have to check them. If you don't check them, you don't know if they're extraneous or not. All right, here we go. So, whoa, look at this problem. We got the square root of x minus 6 equals x minus 8. Well, the radical symbol is isolated. Remember, this is all by itself. There's nothing we can do on the left side, so our first step is to get rid of that. So what we're going to do is we're going to square both sides. Ooh, however, when I square the right side, I got to put the x minus 8 in brackets squared. All right, so here we go. So on the left side, we have x minus 6 equals. And x minus 8 squared means x minus 8 times x minus 8. Oh, no. Here we go again. Oh, my goodness. We're going to have to FOIL that. Oh, man. All right, so let's FOIL that. So we still have x minus 6 here. Okay, FOIL. First, terms. Outside terms. Inside terms. Last terms. Okay, so I'm going to simplify that a little further. So I have this. Combine like terms. Okay, now, recall, ladies and gentlemen, in order to solve this is a quadratic, remember. You have to set it equal to 0. So, in order to do that, we are going to add, come on, you silly thing, add 6. And we're also going to be taking away x. So we have x squared minus 17x plus 70 equals 0. Oh no. In order to solve this, we're going to need to factor. Oh, man. All right, so x. Okay, let's see. Factors of 70 that add up to negative 17. Oh, that's easy. Negative 10 and negative 7. Negative 10, negative 7. So the solutions, we get 2 of them. One solution is 10, and the other solution is 7. Do they both work? All right, well, we're going to have to find out. So I'm going to have to, I'm going to move this down a bit. And we're going to have to use the original problem to check it. So these are the 2 answers that we get. Okay, so we don't know if they're both going to work. Okay, going back to the original problem is this. X minus 6, the square root of x minus 6 equals x minus 8. So we're going to start with the 10. Plug it in. Solve. Yes, 2 equals 2. 10 is a solution. All right. Now we're going to have to check the 7. So I'm plugging the 7 in for x. Okay, so here, here. And I get, whoops, hold on, I wrote that wrong. 7 minus 8 is -1. And no, they do not equal each other, okay? So this one is extraneous. So 7 does not work. So you're going to have to check some of these problems as you're going through. All right? All right, I'm going to do one more. Okay, I'm going to skip this next one, and I'm going to go do one more. Okay, well, no, I'm going to set this one up, but I'm not going to complete it. So on this one, you notice there's the radical on the left side is isolated by itself. The radical on the right side is isolated by itself. Okay, well, you just square both sides to get rid of both of them. They'll both disappear at the same time. Okay, then solve for x. Oh, this won't take that long. Solve for x. So take away x. Subtract 5. So the answer is 2. Okay, that one was pretty easy. That's one of the easier ones. Okay, last one. This one's going to be a bit challenging. Okay, if you have to, pause, rewind, watch it again, whatever you need to do. All right, here we go. Okay, come on, you silly thing. Where did you go? All right. All right, looks like it's ready. Okay, so you'll notice on this one, we have a radical symbol on the left, and there's a -2 with it. And we have a radical on the right, and that one is isolated. Well, there's no way you can do anything with that -2. You could add it to the other side, but then both sides, the radical is not isolated. So you can only get one side to be isolated. So what we're going to do here is we're going to group the left side. And then to get rid of the radical on the right side, I'm going to square it. But remember, I square both sides. So the right side, well, that's easy. That just becomes x minus 2. However, the left side, you're going, wow, that looks pretty bizarre, Mr. Ellering. All right, well, this is actually a FOIL situation. Okay, it is a FOIL situation. So what we're going to end up doing is rewriting it like this. Now, okay, here we go. So the first terms, when we multiply them together, this is what we get. X plus 6 squared. Now, the outside terms, let's see, let's use green. We get okay, and then the inside terms, we get and then the last terms we get, and then it equals, okay, hopefully that made sense. FOIL. So the first terms give us the purple. The outside terms gave us the green, the inside terms gave us the orange, and the last terms gave us the blue. Okay, now I'm going to start simplifying what I can simplify. So the x plus 6 squared becomes just x plus 6. Okay, these can be combined. So that is going to become minus 4 square roots of x plus 6 plus 4 equals x minus 2. Wow. Okay. Now, we're going to combine like terms on the left side. So 6 and 4 can be combined. So okay, now we need to get the square root isolated. All right, well, to isolate that, first we got to get rid of the x, the 10, and the minus 4. Okay, you cannot combine the 10 and the minus 4, though. You cannot combine those. So we're going to get rid of the x first. So I'm going to show that. So I'm going to get rid of x. Notice they cancel out. I'm going to get rid of the 10. Okay, so now I'm going to rewrite what I have. So the x's are gone. Again, on this side, the x's are gone. And it equals negative 12. Cool. All right. Now we're going to get rid of the negative 4. Getting there. 2 steps left. Get rid of the square root. Subtract 6. And our answer is 3. And you could go ahead and check that one, and it will work. Okay, it will work. All right. Good luck. Practice those. Okay? Practice, practice, practice. All right, thanks.